I think, the most insightful part. It's something we internally call in the company product algo fit. There's a lot of really great capabilities, algorithmic capabilities that people build, but now you need to find the right way to manifest them to actually, make a product that utilizes these algorithmic capabilities in a way that is useful for customers.
Yeah, product algo fit is a fun one. I've not heard it. It's such a thing right now where you see these models that unlock new capabilities, and the question is, what do you actually build with it? Like, what is the useful thing? And so balancing research and product is a very non-trivial thing to get right. Hi, Ori. Thank you so much for coming on. I'm excited to get to chat with you today about AI21.
Yeah, excited to be here. Thank you for having me.
Before we go into the future and how enterprise is going to change completely with agents, we'll go backwards first. So you have this incredible group of superstar AI co-founders and a really impressive background yourself. What problem were you guys trying to solve in 2017 that most people just didn't see yet?
Yeah, really all the compliments for my partners and the team. It's a really, really incredible and very special group we have at the company. We started the company back in 2017 with the idea that deep learning is necessary but not sufficient. And in many ways, this statement is actually more relevant today than it was back then when we started it. We were seeing, how powerful these deep learning systems are, and obviously we've seen the progress in the last few years of what can we do with these large language models and now large reasoning models. And it's very impressive. But with that said, there are certain problems, certain areas that are more deterministic by nature, and they require also more kind of predictable approach, because not everything needs to be kind of computed by probabilities, by just probabilistic methods. Some things needs to be addressed deterministically. And so that was actually the reason why we started the company. We said, these deep learning neural, net-based systems are amazing, and they're not going to go away. On the contrary, they're going to thrive. But on the other hand, there needs to be a complementary approach to solving complex problems. And so the premise from the get-go was to create these reliable AI systems we can actually trust. And in many ways, we're just starting to realize that vision today. And that's what makes me, so that's why I think this era is so exciting. There's so many big problems to solve.
When you said, okay, look, like deep learning is not sufficient, there are some things where you actually just need a deterministic system, and you need some hybrid, some symbolic and some neural hybrid approach that lets you do a little bit of both. When you set out to go after that vision, what in your mind was the biggest risk? Is this technically possible? Was it technically validated and you needed to go and prove that companies would use it? What did you view as the biggest risk starting a company, beyond the general risk that always happens with starting a company and execution?
Yeah, exactly. It's, you mentioned neural-symbolic. I think it's like oil and water. So there are many ways to realize this conceptual idea. And we basically had, when we started the company, we had two principles. One is we wanted to focus on natural language. Back then, AI was completely dominated by computer vision and various predictive.
Yeah, natural language was cool kind of like a few years before that, and then came out of the limelight for a little bit.
Exactly. So we wanted to focus on natural language. We really believe this is kind of the next frontier. And second, we wanted to build real commercial value from the get-go. And so kind of given those two principles, I mean, there was an inherent risk in terms of, how can we apply the technology, how can we kind of move with the technology, and apply it, and to actually make significant progress on the natural language front, but also find, where it's mature enough to bring value and translate into real commercial applications. And so that was actually what kind of kept us busy in the first few years of the company. And then, and of course, we can discuss kind of our journey. Then we found, several facets, several ways to actually realize and provide commercial value for users and customers globally.
I'd love to hear about that initial product journey. And then we'll talk about how ChatGPT changes some of those things. But what you just mentioned in this B2B camp is you want to be natural language focused. You want to provide real value to enterprises. And if you look at what you're doing today, that's definitely true. But you also had this B2C focus with Wordtune. So tell me a little bit about initial product. How do you actually make this happen, and how you balance the B2C side with the B2B camp?
Yeah. When we started, and we were one of the first companies in the world to train language models. We haven't called them large language models back then. I think the first time kind of the name popped is when people trained like 700 million parameter models. That was considered large. But in any case, we were amongst the first ones to train LLMs, and we tried to find applicable markets. And we looked at the enterprise and kind of where the technology was and what were the needs, and it wasn't like a clear fit. But back then, we have seen that actually these relatively small language models were quite effective in helping people to better read and write. And so that, as we understood that there is no enterprise market yet, we kind of decided to create our own market. And we built and shipped an application called Wordtune, which was basically the first AI-powered reading and writing assistant. And initially, what it did is basically rewrite, rephrase the text as you write in a very convenient manner, and also summarize like lengthy articles or websites, so people can consume content much faster. And it did it pretty well. I mean, the application, in the first few years, it received like several tens of millions of users, and a large user base of paying customers. So it was quite a successful endeavor. Having said that, I mean, our original mission was to create these reliable AI systems, and as things in the market change, especially with ChatGPT came out, and it was an eye-opening moment for the entire market, including the enterprise market. That's where we realized we actually need to shift our focus and kind of go back to our original mission. Yeah, and focus on that segment of the market. If we're, just as a quick history, if we're at it, we back in 2021, we actually released our first large language model called Jurassic 1. And back in the days, it was slightly bigger, slightly better than GPT-3 in many aspects. GPT-3 was 2021 was the kind of the state of the art. And so, and that's when we actually started pivoting towards the B2B space, when we sense, okay, these models are capable enough that create a lot of value in the context of an enterprise.
Did you view this as, okay, we're now pivoting our focus? Maybe there's the same underlying model, but we're pivoting the focus. Or are there concrete learnings that you had from Wordtune as well that you incorporated and then became applicable to enterprise?
Yeah, I mean, there are many, technological learnings and product learnings. Um, it's in many ways these are, very very different dynamics. I mean, selling to enterprise versus, serving consumers is very very different. Um, but I think there's some fundamental, learnings we've made along the way of, how to iterate around a product, how do you um, serve customers, how do you reach. Maybe that's, I think, the most insightful part. It's something we internally call in the company product algo fit. I mean, um, there is, there is a lot of really great capabilities, algorithmic capabilities that people build, but now you need to find the right way to manifest them to actually, make a product that utilizes these algorithmic capabilities in a way that is, useful for customers. So
Yeah, product algo fit is a fun one. I've not heard it, but it's such a it's such a thing right now where you see these models that unlock new capabilities, and the questions, what do you actually build with it? Like, what is the useful thing? And so balancing research and product is a very non-trivial thing to get right.
exactly, exactly, and that's something that there's always this tension, between things you can do in the lab, so to speak, and how do you actually translate them into something meaningful and useful for customers. Um, and throughout our journey, we kind of understood the arts of how do we, on one hand, we're a deep tech shop, so we build, we build models, we build AI systems, we have a lot of algorithmic innovation, some of it we've published, but how do you kind of balance that and actually product delivery, and that's something that took us, we are still learning and we're still perfecting as we go along this journey.
Let's talk about product algo fit, and we'll start on the algo side and then we'll move to the product side. So on the algo side, you mentioned Jurassic, and we'll talk about Jamba too. But first, I'm actually just curious to hear, there are not a lot of folks. You mentioned you trained the first, maybe you didn't call it a large language model, but you trained a language model that was large. And how do you find the right people to do that training? It's a skill set that is really hot right now in Silicon Valley. People pay a lot of money for folks who can train models. So I'm curious what it takes to train up the team, especially now there's more precedent in the market and people moving around in these companies to get that right.
Yeah, there's more precedent in the market right now. Back then, there was no talent because it was basically a new field.
So how do you train
I think you need a combination of people with, algorithmic understanding and kind of be, you know, um, have the theoretical background on one hand, and on the other hand, are really strong engineers, because there, a lot of the problems, like with these very large training workloads, a lot of the problem is around it's like system engineering, distributed systems, distributed computing. You run large clusters, things tend to break. How do you compensate? How do you overcome all these issues when you train at large scale? I mean, this is like, if you take a typical researcher, out of academia, and there are obviously a lot of very smart people. I mean,
this is not what they spend time on.
yeah, exactly. So you need that combination of people on one hand, get the theory and kind of understand the underlying algorithmics, but on the other hand, have the engineering chops. So
How do you identify the best systems engineer? I mean, I know you have a background in 8200 as well. I'm sure there's a lot of talent from those days, but recruiting and getting a team to do this is non-trivial. So any tips?
yeah, it's non-trivial. I think it's very different back then. like 2019, 2020, it was there was no such talent basically out there. I think my advice would be to think globally. I mean, people are gravitated towards Silicon Valley, and of course, most of it, I would say, it's probably the most dense, zone area in terms of that type of talent. But there's so many talented engineers elsewhere in the world. Some of them actually did have some experience with training models, even in a smaller scale, and can extrapolate from that. But also, I would recommend people to look at um, just other engineering practices. I mean, people who've been in storage or low level programming, or like low level engineering, or um, all of these hard problems, that so they have lots of talented people there. I mean, and for them, kind of doing the switch and kind of learn about deep learning and these probabilistic systems, it's not rocket science, so to speak. So these folks could be converted to be highly effective for deep learning and system engineering and so forth.
When we talk about product algo fit, and so you get these great systems level engineers, low level engineers working on the algo side. How do you then? So the way that you described it is there's these new algorithms, and we figure out the right product. But there's also the reverse of that, which is how do you think about like orienting the models that you build around what can actually be useful? So what does that relationship look like in practice on your teams when thinking about product algo fit? And then maybe you can use Jamba as an illustrative example of why that's the next model that you built, or the most recent model that you've built.
Yeah, at some point we kind of realized the model is a product, and we want to think about it like, yes, there's a lot of technical innovation. So maybe kind of one way to look at it, you want on one hand for the researchers and engineers to give them the level of freedom to innovate and think about things from kind of a first principle um, point of view, so they can come up with a new architecture, or they'll have the foresight to understand where things are going. They'll have kind of the experimental freedom to discover interesting and useful things. So that's on one hand. On the other hand, they need to have very kind of clear goals and targets that you can be manifested through like product requirements. So what benchmarks, and what the model should be really good at, what kind of skills the model should have. So those are the kind of things that we think that are almost like product decisions. I mean, there should be product led. So there's this delicate balance, and when we, just to be kind of concretely speaking, when we started the Jamba project, which is our own foundation model, um, we wanted we wanted to focus it towards the enterprise. So we thought about the types of use cases and uses that the enterprises are having, and I think it was quite obvious that most of the use cases are kind of retrieval based. I mean, you need to retrieve a lot of context into the model. So we wanted to design a model that is best in that setting, that can deal with a lot of data in the input, like a very large context window. And we wanted also to bake in skills that are more common and popular within enterprises. So the combination is basically kind of what led into that kind of product algo fit between the innovation that was put into the underlying architecture on one hand, but on the other hand, the skills and the types of tasks that the model excels in.
So let's actually talk about that. Why is the Mamba Transformer architecture the right one in order to do that?
Yeah, so So as I think people very well aware, these models are these large language models or foundation models that are computationally expensive. So and most of the models out there are based on the transformer architecture, and which is quadratic at inference time. Quadratic complexity at inference time means the more you scale the context window, the input, the more computationally expensive it is. And so that's not very scalable. Like if you have 2,000 tokens in the context window, that's fine. But if you have like 200,000, that's a different story. And then you pay for it, like you, the developer, is paying for it in terms of latency, or just need more compute to compensate for that latency. And so, it, like almost in adjunct to kicking off the Jamba project, the Mamba paper was published, and our researchers really looked into it and all the evaluations and ablations in the Mamba paper. And we've also experimented with this architecture ourselves, and we found that there are certain types of tasks.
Just to clarify, what does experimented with the architecture mean? Does it mean training a smaller model and seeing what does that actually mean in practice?
Yes. It means training a smaller version of the model, kind of, and for example, in this case, a same size version of a transformer model, and kind of have a test bed where you can compare, empirically compare between different architectures and different settings. And the Mamba paper, which was published back then, it showed how you can basically get almost similar level of quality, but at much more efficiently, because the Mamba architecture is linear complexity at inference time. So the more you scale the context window, you pay more, of course, but not as much as you would have with transformer-based architecture. And so it's
Yeah, I don't
really,
know if you
it's
know the folks from Cartesia who have been
yeah.
building on state-space models in audio. So had Karan on the other week too.
Oh,
I,
cool.
I'm curious what becomes the biggest challenge in building this joint architecture.
Yeah, I mean, a lot of, so this is exactly, so our what the innovation that our researchers have made, they basically uh, showed that the combination, there's a lot of ablations, and that's part of the challenge. How do you make these ablations? And there were a lot of ablations to be made, and they found a setting where, for a variety of tasks, not only you can get the enjoy from the efficiencies of Mamba, but interleaving transformer layers in a certain setting, you also get better quality. So this takes a lot of experimentations, because the option space is pretty wide. I mean, there's a lot of different settings, a lot of way to um, kind of combine, um, and so that's how do you explore that space. It takes some intuition, some understanding of the kind of underlying architecture, and just having the compute set up and all the infrastructure to experiment at scale. And also a lot of things that um, you can see in small scale, not necessarily reproduce at high scale. So that's another challenge, because you still have that that part, which is still like an unknown of would it actually scale if I work in a larger settings. But anyway, so our our folks have found a really neat combination between Mamba and Transformer, where you can basically enjoy best of both worlds: the quality of the Transformer architecture and the efficiency of the Mamba architecture, and we published a paper kind of specifying all the experimental activities that we've done and the results, and we're very happy with the contributions as well.
I assume when you go to enterprises, they don't. Well, I'll be curious what you say. My assumption is they don't care that you have a Mamba Transformer architecture. They care that now you can accommodate longer context windows, for example, and increased efficiency, et cetera. So I'm curious what it then takes to bring something like a Jamba into the enterprise. How do you convince them to trust your model, to use your model, especially since it may be non-trivial for them to test bed it with all of their rich data, because then you're starting to plug into the system?
So first of all, we open weighted the model. We put it on a Hugging Face. It became very accessible. We've made it available through our own SaaS platform and through our partners. Like it's available on Bedrock and Vertex and Model as a Service. So it's pretty easy to consume, like any other model. But you're absolutely right. I mean, enterprise customers, they don't care about the underlying architecture. I mean, they only care about the capabilities, and I think one way for us to take this to market is go after the more advanced customers who've already implemented several generative AI use cases, so they had more, mileage and understanding of what are the challenges. Because customers in their early journey, I think they were even like latency and cost, and there were like secondary considerations. They first want to see something that is live and provide value and so forth. But then when we went to more sophisticated customers who've had several production workloads at scale, and they started thinking about these considerations, then it was a very easy conversations, because also some of these sophisticated customers actually do understand the underlying, like the reasons why transformer-based networks are limited, and luckily, and I say this, I just very fortunate to have such a strong relationship with our customers and partners. They've realized, like, okay, this is actually where the future is headed. Like in 2-3 years from now, this is going to be de facto the standard in and so we better bet on this architecture early on, if this is where the pocket's heading.
Well, to say they don't need convincing is to trivialize all of that other work that has led up to them not needing convincing, but they're sort of on board and they say this is the future, this is the bet we'll make. I'm curious in general, including for those that are not, maybe not fully bought in yet, how forward deployed do you have to be? How much because each enterprise is different, the use cases may vary. When you're selling into the enterprises, how much does your team need to do in terms of education, in terms of instrumentation, et cetera? Because it is still, it's different than it was a year ago and different than it was 2 years ago. And I'd be curious what you've seen over the last 2 years in terms of customer readiness and appetite, but still how much hand-holding needs to be done at this point in time.
First of all, things move super fast. I mean, if I would need to describe it, I would say, 2023, kind of post ChatGPT, was the year of sporadic experimentation. 2024 was massive experimentation, and 2025 is where we're going to production, roughly speaking. And I think there's enterprises haven't really scratched the surface in terms of adoption of these models and systems in production. I mean, just we go to a typical enterprise, and you'd see that they have maybe tens of use cases in production. It's a good enterprise, but there are thousands in the backlog. Um, there are many reasons, but I think the main reason is reliability. I think it goes back to that point. Having something deeply rooted inside critical workflows, it needs a lot of trust of these systems, and we're not there yet. And even the kind of the use cases that are heavily engineered and get to, I don't know, 85 or 90% accuracy, um, in some cases it's just not good enough. So reaching accuracy at scale, it's really one of the barriers for mass adoption in the enterprise. And kind of go back to your question, I think that we're still in a point where, to take critical workflows and use cases to production needs a lot of hand holding, because most organizations don't have these chops in house. And um, and even if they have like very capable engineering teams, not necessarily ones with a lot of experience with these models and systems, so they do need, in many cases they do need some hand holding.
What's the primary thing that they need need the hand holding for? Or in other words, is there a problem that you're consistently seeing that folks need a little bit more guidance on?
Yeah, I mean, even I think the most challenging part of each project is the evals. What success looks like.
You definitely hear that a lot.
Yeah, that's the most challenging part. So you need to find a systematic way to build a robust eval that actually represents the problem. Because sometimes people, they're making evals, but it's very skewed. It's not really representing the natural distribution of the problem they're trying to solve, and then you're optimizing for the wrong thing. So what I'm saying here is, like, building a good eval is a key, and then you can iterate and optimize, and there are so many techniques you can actually use to either fine tune or prompt engineer, or build like a chain that can address that set of problems. So I think that's kind of number one on the list. The second thing is, just think about how to architect the systems. I mean, again, this is non-traditional software, not non-deterministic software. So you need to think about, how do you put the right guardrails in place? How do you kind of make sure the system don't derail? And people need a lot of help there. Um, and um, generally speaking, I think that production readiness is challenging, and that's very holistic. It kind of gets to what is the latency requirements, what are the cost profiles, guys, because there are different options. You can use smaller models, larger models. There's so many design choices that needs to be done.
Yeah, absolutely. But rejiggering the design, knowing if you can do the smaller model or if you should use X or Y, hinges on, are you evaluating that it's doing the right thing in the first place? And is it going to
Exactly.
go off the rails in some way because you don't have the right guardrails in place? So, okay, that makes sense. How, given this nature of working so closely with enterprises, tell me a little bit about Maestro. Why is that something that you all decided to spend time and focus on?
So Maestro is it's first of all, it's a platform we released recently. It's an AI planning and orchestration system designed for complex tasks. And or another way to think about it is a platform for developers in the enterprise to build agentic workflows or agents. By the way, I shy away from the term agents, because I think it's very overloaded and people use it many different things.
Well, I was going to ask you, when you say agent, what do you mean? So
Oh,
maybe I'll give you a pass, but define it in your words.
yes, that's a whole lecture. But anyways, so I think it's pretty clear right now that when you think about AI in the enterprise, it's going beyond models. You have these more comprehensive systems, and then the problem we're trying to solve with Maestro is to reach accuracy at scale. Basically, how do you get the level of reliability that will allow you as an enterprise to go from the tens of use cases you have in production to thousands? And how do you democratize this within the organization so every engineer could actually build an agentic workflow, but not just as a demo or a POC, but one that is actually ready to deploy in production. That's the kind of the grand mission of the Maestro. And the way it does this, the way we figured, because we've been operating in this space for a while, we saw that to actually get a system ready to production, there are many of these design choices that I mentioned earlier, like which model to use, how to prompt it, which retrieval strategy to use, how do you kind of embed the information, and you can use different chunking strategies and so on and so forth. There are many things, and people, they um, they we always say that currently the way these systems are built, developers go either they kind of prompt and pray, they take an agentic framework and they take an LLM. That LLM is functioning as the controller, the one that decides what to do next and how to operate a certain task. But LLM are not designed to do it, and that's why people, we call it prompt and pray, because people specify it in the prompt and they try to optimize things in the prompt and they hope for the best. And people realize that this is, just not reliable enough. So they go the other direction and they work around that and they build these static chains. It's like a hard coded um, programs, and that it's almost like a scripted scenario, and so that gives more control, and in some cases actually more accuracy. But on the other hand, it's very rigid and it's very hard to scale because you need to build such a chain for every use case. So we thought there needs to be basically a AI for AI systems, if you will. There needs to be like an engine that can get all the models, all the tools of the enterprise, and all the data sources. And it needs to, given a task that is described in natural language, it needs to create an explicit logical plan of how to solve that task, but also an operational plan with all these design choices that I mentioned earlier, like which models to use and how much to validate and fix and so on and so forth. And execute that plan, that operational plan in a smart way. And so we think, so this is conceptually, this is Maestro and the way it works. But all these things are just designed to abstract away a lot of the complexities for developers while giving them a lot of control and reliability.
How do you strike that balance, or kind of like, what is the big challenge in getting Maestro right? And maybe even before that, I'll ask a related question, which is, building a product like this looks very different than training a model like a Jamba. And so is it just obvious to you, given that initial vision that you talked about, we want to deploy natural language in the enterprise, we need to do this? Or was this an internal debate and question? Does it make sense to expand our product offering and have something that is adjacent here? So I asked you two questions, but a little bit of the behind the scenes and actually making something like this happen.
Yeah, I have to say, it's always a question of, it's more a question of when than whether for us,
Yeah.
because it was
Okay.
always clear for us that you need to go beyond the models. um, and so it's really, and we've been experimenting with this concept of, going beyond, going from LLMs to AI systems years ago. It's just now we felt this is the right time to introduce a product or a platform to the market. um, I'm sorry, what was your first question?
That was part of the question. And then the other question is, how do you make the product decision that allows for, like, I guess, how do you spec it out and have that balance between flexibility and rigidity? What goes into specing the product and who does it on the team?
The idea is that you have an engine that speaks in a formal language. I mean, it's not unlike reasoning models or any of these, model-based approach. It's more grounded because you get an explicit. You can always interpret what the system does. It's generating and it's operating under explicit plans, even if the plans changes along the way and there's replanning, but it's still an explicit um, plan in hand, and that conceptually just gives you a lot of kind of expressive power. It and explainability, and so in a way, this is our the basis for providing more control and really reliability over the results. So yes, there is a delicate balance to strike here between how much um, explicit and kind of rule based you want to be, and how much more soft and flexible. And our goal was to find a sweet spot. So on one hand, you'd be able to specify everything you want in natural language. On the other hand, behind the scenes, the engine would speak in a formal language that can be interpreted and could be reasoned over. And that's kind of part of the philosophy that we used from day zero, basically.
So if this succeeds and we see more agents in production in the enterprise as a result, what does AI in the enterprise look like in 5 years?
We've spent a lot of time thinking about this in the company, actually. And there are a lot of terms in the industry, like artificial general intelligence and super intelligence, and we actually like to think about a different term called super productivity. We think that once we'll have these systems deeply integrated, it will not only um, I think people think about it, how much of our work can we automate, how much efficiencies can we gain, right? And we actually think about what organizations would aspire to accomplish, given such such given an era where you can operationalize your ideas fairly cheaply because you have these systems in one's hand. And so we do think like a lot of the more strategic thinking that AI is not very much deeply involved today would actually, so given a manager that needs to make a decision and can think about like in his head, people are thinking about different scenarios and how this, that, or the other will pan out. So now you may have like a system that have a rich enough context, but is also capable of running these scenarios for you. I mean,
Yeah.
this sounds really science fiction, but I do think
And they always say, like, you can't parallelize your life, but in some ways it condenses the timeline in which you can.
exactly, and kind of reimagine what's possible, right? Making decisions, maybe even making meetings for us. Like if there's a coordination problem between, or not problem, but there's just a coordination need between marketing, product, and algo, and so maybe I can, delegate to my, agentic system to run the meeting for me, and and represent me in a way, and kind of reach out to conclusion. There's I think the future is so exciting. I mean, 5 years, it sounds like, sounds like a lot, but I think we're going to see some drastic changes by then. And I think we will get to a point where almost these, agentic workflows that I mentioned earlier, and the kind of the set of use cases, they become the enterprise itself. They become the operating system of the enterprise.
I love that. And, I'm curious also what you think about AI in Israel. So I'm not there, I'm in the Valley, but I try to visit often. What are you seeing on the ground?
I think, Israel is probably one of the most promising, places for AI development, and mostly on the application side. I mean, just think about the Israeli ecosystem. We've had a history of where there's a new technology wave. There's just incredible, unbelievable amount of innovation created around it super fast. I mean, think about the early days of mobile. Just after post iPhone, like, a couple of years after, you had incredible amount of innovation and entrepreneurship activity here in Israel. I mean, think about Waze, think about many of other successful applications that came out of Israel. When there was no background, there was no almost like zero background in consumer applications. Right, in just several years, it popped.
100%. Yeah. There's a I mean, with everything going on, rightfully so, a cyber reputation, but more and more of these.
Exactly. Cyber, we have a long history. So I think the same thing will happen with AI. I think there is a phase shift in a way. We are very proud and honored to be the Israeli representative in this small cohort of companies that build this foundational technology. I mean, essentially, if you think about the independent labs in the world, you have OpenAI and Anthropic in the US, and Cohere in Canada, and Mistral in France, and AI21 is the Israeli company. So we're very honored, and we hope to build an ecosystem in Israel that is just taking that product algo fit to the extreme, and find new ways to manifest the value that is
Taking the algo and making the best products, basically.
exactly, and I think there's just incredible potential there.
I love it. Okay, I'm going to ask you one more question, which is, um, you have this awesome background from leadership in 8200, previously founding and selling two companies. I spoke to Olivia Gorvey on your team too, who just said you're like this fantastic leader, culture bearer, work hard, get shit done. I'm curious how you've changed the most since starting AI21 as a leader and as a person.
Oh my God, I changed a lot during the last couple of weeks, but
Good. Every day
uh,
changing, like the models.
they're not changing rapid enough, though. No, I'm just kidding. Um, so yeah, I mean, I think I personally changed in many ways. This experience has shaped me deeply. First of all, it's being in the eye of the storm is such an unbelievable. It's unprecedented, the market we operate in, and just the pace of change is incredible. So you have I think one thing I would say is to develop just incredible amount of resiliency. I mean, you have to be resilient in any entrepreneurship journey, but in this particular one, I mean, in order to survive, you really need to have.
Well, because the tides underneath you are changing all the time, so you have to be really, really steady.
Yeah, I mean, and even for the ones in our industry, and we even with our competitors, we kind of share experiences, and even for the more stable ones, I mean, they it's more stable than it seems. I mean, it's less stable than it seems. And I think I've heard from one of my colleagues, like in a different company, saying, "I hope this week nothing comes out that changes my entire roadmap for the year." So it, it is a very it's an incredible um, and with it's just an environment with a lot of uncertainty that you have to navigate. I think if there was one thing I learned is to stay very truthful for your original mission and what you're actually trying to accomplish, and um, stay away from detours and shortcuts, because longer term, I mean, it just won't do any good service for the company. But it takes a while to understand these a lot of painful, a lot of lesson learned, to actually internalize this.
Totally. I mean, I think when things move so quickly, it's easy to, I don't even know if distracted is the right word, but to say, does everything get turned upside down? So I need to move in XYZ new directions. So thanks for sharing that. And thanks so much for coming on, Oli. Really appreciate it. And excited to see the future of Maestro and Jamba and everything else to come.
Awesome, thank you. That was great fun. Thank you for having me.
Thanks for coming.